Welcome to Ask and Learn.
All right, guys, we're doing problem number 60 in Chapter 5, Chemistry Essential Science. So, under constant volume conditions, the heat of combustion of benzoic acid, which is going to be C7H6O2, is 26.38 kilojoules per gram. A 2.76 gram sample of benzoic acid is burned in a bomb calorimeter. Temperature of the calorimeter increases from 21.6 to 29.93 degrees Celsius. What's the total heat capacity of the calorimeter? In fact, let me change this. I'm gonna instead of Q over M. Yeah, Q over M is fine. So we're gonna be using the formula Q is equal to C delta T. So we have Q. So we have Q here. So we're gonna multiply this by our mass, which is 2.760. That'll give us our heat. So Q is equal to 26.38 times 2.760. Equal to 72.8 kilojoules. So we're going to rearrange, that's our Q. We're going to rearrange this. So this is going to be Q over delta T is equal to C. So 72.8 divided by 8.3 which is equal to us 8.74 kilojoules per degree Celsius, which is equal to our C value. Now, for part B, we have a 1.440 gram sample of a new organic substance is combusting the same calorimeter. The temperature of the calorimeter increases from 22.14 to 27.09 degrees Celsius. What is the heat of combustion per gram of the new substance? So we're going to put as so Q over M is going to equal C delta T M. So Q over M is equal to our the heat capacity of our calorimeter is 0.874 kilojoules per degree Celsius. And our temperature, that's going to be 4.95 degrees Celsius. And we're going to divide that by 1.440 grams. So that means Q over M is going to be equal to this equation, 8.74 times 4.95 divided by 1.44. So Q over M in this case, that's going to be 30.04 kilojoules per gram. So now, for part C, they wanted us to know, suppose that in changing samples, a portion of the water in the calorimeter is lost. In what way, if any, would this change the heat capacity of the calorimeter? So if you have, so let's say you have, sorry, the water from the calorimeter is lost. So there's less water to heat. So if there's less water to heat, then it's going to be easier to raise your temperature. So if you're producing the same amount of energy from this reaction, it's going to cause a larger increase in your calorimeter temperature. So we're going to look at, so remember this formula, Q is equal to C delta T. So if Q is constant, and let's say if Q is constant and temp delta T is increasing, delta C has to decrease in order to keep this constant Q. So that means if water is lost, then C is going to decrease as delta T increases. Yes, and we all understand. You're producing the same amount of heat, so you're as for less water. So that's going to cause a higher increase in the temperature. So you're going to have a smaller heat capacity because it's easier to reach that same temperature.